Okay. All right, so I hope all of you are here for getting started with Kafka. If you're not, still stay. If you are, welcome here. My name is Nikhil Nanivadekar. I am a project lead of Eclipse Collections, and Eclipse Collections, the website for which is eclipse.org/collections. It's a Java collections framework, completely open source under the Eclipse Foundation. Feel free to go there, take a look at it. If you like it, put a star on the GitHub repo. We are here to learn Kafka. So can anybody tell me what is Kafka? Anybody? Just one person. Come on, help me. Yes, sir. Yeah? Yeah. Okay, so the answer was it's a technology for processing or streaming large amounts of data. All right. In reality, Kafka is nothing but a transaction log. Okay, so transaction log is similar to your database transaction log. Essentially, when you're looking at the log and when you replay the log is the ultimate source of truth. Okay. Now, where does Kafka actually play where does Kafka play a role in this entire developer ecosystem, or in this myriad available tools and frameworks that we have? Okay, so Kafka is, in my opinion, one of the best technologies where your producer and consumer are decoupled. Okay. So what does that mean? A producer can go on producing data at its own rate, at its own frequency, and the consumer can go on consuming data at its own rate or its frequency. Okay? For example, in my previous talk of getting started with Spark, I gave an example of the registration process of JFocus, how it was distributed and everything. So I'll give a similar process, like it's registration itself. Now think about it this way: if your badges which were there, they had to be printed like at that particular instant, as and how you came, right? How long it will take? There were 2,000 people who attended JFocus, and they had to print badges for each and every person on the spot, and they had just one printer, okay? Think about how long you'll have to stand in the cold, right? So what they did was, instead of that, they ended up producing the badges beforehand, and as and how each consumer came and picked up the badge, they got their badge. So essentially, the production of the data was done at a certain rate beforehand, and the consumption of data was done at a certain rate at some later point in time. Okay? The data was available for it to consume. Okay? Another reason why Kafka is so important, or in my opinion is so important, is because you can have one producer and multiple consumers, and the consumers consume data at their own rate. That means the data consumption of different consumers do not affect each other. Okay? Assume this that it's a file-based system, okay? And a producer FTPs a file, and that same file is consumed by 5 different consumers. Okay, 4 consumers have finished consuming the file. The 5th consumer failed. Okay, let's say their host went down, or there was some other issue, etc., etc. Now, essentially, until and unless the 5th consumer has done consuming the file, these rest 4 consumers who have actually done their job don't get the new set of data. Okay. So even consumers are coupled in that process, right? In Kafka, your consumers are also decoupled. Does that make sense? So that's where it comes into action. Now, since this is a quick 15-minute lightning talk, I'm going to directly go to the demos. Essentially, Kafka has 3 components, or more than 3. The very first important component is your zookeeper. Zookeeper is the one point of failure, essentially. What ends up happening is Kafka uses the zookeeper instance. I hope this comes up. Kafka uses zookeeper to essentially figure out all the master nodes, all the producer nodes, all the consumer nodes which are there. Okay, and essentially in Kafka, you have something called as a Kafka topic. So we'll look at these topics really quickly. The next one is actually starting a Kafka server. So essentially, your Kafka server is nothing but another server which comes up and registers itself to Zookeeper, saying, hey, I'm available to get the data and push the data around. All right? So basically, it ends up connecting to the consumer and says, all right, I have started, and now I'm ready to subscribe to a topic. I'm ready to, more than subscribe, I'm ready to host a topic. You can give a topic to me, and I will keep it. Okay? So what that means is, essentially, I can just create a topic. It's a test topic, which has one partition and one replication factor. A partition is basically a means in which you can logically group the data, and you can increase parallel processing. Replication is essentially a means in which you can achieve redundancy by copying over the exact same data. Okay? And in a Kafka cluster, when you have more than one server, one server is elected as a leader, and other servers are elected as a follower. And what Zookeeper does, one of the jobs that Zookeeper does is, if a server goes down, it ends up electing another server as the leader. So whenever you push any data to the topic, it first goes to the leader, and it's leader's responsibility to replicate the data across its followers. Okay? What Kafka guarantees that there will always be data consistency as long as there are replication factor -1 servers available. Okay? So right now, it's just one laptop, so I'm going to use replication factor of 1, but you might have replication factor of 10. That means you have 10 hosts or 10 servers available. Until unless you have 9, if one goes down, Kafka is not going to stop. So that makes it fault tolerant as well. Okay? It's fault tolerant and recoverable just by the virtue of redundancy. Okay? So we saw the Zookeeper. Zookeeper is responsible for maintaining, basically the metrics of all the topology of everything that is available. Then we saw a Kafka server come up. It's nothing but a program which says, hey, I'm available to host a topic. We created a topic called as test. Now let us create, after the test, let's actually have a producer produce data. So, okay, this is the producer. While it comes up. So producer is another of your topics. Producer is another of your processes, which is essentially generating the data, which you want to push to a topic. Basically, a producer is where the producer is up now. Now, whenever I say this is, not here. So the left side is the producer, the right side is the consumer. This is a message. Okay? So the producer has produced the data, right? Till now, there is no consumer available, all right? So this is another message. What does that mean? Your producer and consumers are completely decoupled, right? It does not matter if there is anyone consuming the data or not. The producer is doing its job, okay? It's like separation of concerns. It's separation of responsibility, all right? So let's quickly bring up a consumer as well. And essentially, you bring up the consumer and say that, hey, I want to bring it up, connect it to this server, and I want to subscribe to a particular topic. All right? Now, the moment the consumer comes up, it sees that, hey, there are messages on the topic, and I'm going to go and read those messages. Okay? So you will see once it comes up, which is any second now. Yeah, there you go. So it came up, and it consumed, this is a message, and this is another message. Now, if you see here, I will say, this is the third message. All right? So the producer produced, the consumer consumed. Okay? So what I can do is I can bring up another consumer, okay? And at that time, the consumer will start actually consuming data from wherever it wants. So it might want to start consuming data from the latest message or from the earliest message, okay? But these two consumers are completely decoupled. And in the last 5 minutes, I want to explain the basic concept of how it is achieved by something called as offsets. And then I will open it up for questions. So the way Kafka ends up decoupling the consumers and the producers is, first of all, there's redundancy. Then second thing is this is a concept called as offsets. Okay? Offsets are nothing but essentially IDs given to each of these messages. Okay? Each time a producer pushes a message to a Kafka topic, it is essentially pushing a message to the transaction log. That message gets an ID. Okay? The moment that ID is there, that ID is something which each consumer tracks. Okay? Zookeeper is responsible to keep a track of which consumer is at which offset. Does that make sense? Okay, so now if I end up, let's say for example, I just bring down this consumer, okay? I'm going to say this is the 4th message, okay? Now, whenever I bring up another consumer, which is there, it won't be the same consumer because I've already brought it down. It should read everything from the first message, okay, from the earliest message, right? So all the 4 messages should be read again. And the reason for that is the offset of this new consumer is at 0 when it begins. Okay? It's completely configurable. You can configure whether you want to go at the latest or whether you want to go at the last one. So right now, let me actually. Here, in this case, it is written so that it will end up reading on the topic test. As a part of test group, you will see there is something called as a test group, right? It is going to read from the latest offset. So this is the 5th message, okay? Now, see, this is the 5th message, 6, 7, 8, 9, right? Now, because in that test group, okay, in the consumer group, the offset was already at 4th, then 5th, then 6th. Now what I'm going to do is I'm actually going to kill this consumer, and I'm going to bring up another consumer with a different group, okay? Just test group 1. Now you will see if I'm not wrong, hopefully. Come on. Yes, so there you go. So now a completely new consumer came up, and it actually read from the very first, okay? This is how. And I can bring this down again. Now, here's the fun part, right? I can bring this down again, and I say 10, right? 11, and now in this case, I'll bring another consumer up with the previous group, okay? It's called test group. At that time, we were at 9, so only 10 and 11 should come back, okay? And that's all achieved by offsets, because at the end of the day, Kafka is nothing but a transaction log with the exact same, concept of the log being the ultimate source of truth. And the offsets are your message numbers or your IDs. Okay? 10, 11, and I will do the same thing for test group 1 as we had seen. And it should also show 10 and 11. And then I can also bring up 2, but we are almost out of time. Is there any questions? I think I have time for one question. Yes? So the question was, is there any way that Kafka will not lose messages? So first of all, as long as there's a Kafka cluster running, a server running, and there's a producer producing to a particular topic on that server, Kafka will not lose messages. As long as all your redundancy servers have gone and basically your cluster has come down to 0. Kafka makes sure that using the strategy of replication, those messages are essentially never lost. Even if a server goes down and comes back up, the leader synchronizes and says, hey, we are at 50th message, you're only at 40. Go, get these 10. Okay? So by the idea of redundancy, or by the virtue of redundancy, you're not losing messages, unless everything just goes, it's a complete wipeout. Okay? All right, thank you everybody for coming. It was a lightning talk. This was my very first JFocus, and I'm basically in love with the audience here. Thanks for everybody being an amazing, amazing participant of the conference, and it was lovely to be here. Thank you, everyone.